All right, in this module, we're going to start going over the various parts of the SEM, and in this module, we're going to focus on the electron gun, or how we produce electrons. All right, so the most common type of electron gun that we have, so source of electrons, is known as the thermionic emission gun, and that's what you see here. More recently, more recently, we also have field emission guns, and these are actually becoming more and more popular because they have higher brightness. But I first want to sort of go over sort of the classic thermionic emission. So there's effectively three main components that we have, and you see those listed here. So the first one is the cathode, which you see here. Think of this as a filament. And so the most common type would be tungsten filament, but it could also be lab6, LAB6. That's another type. But basically, the thermionic part of this means that it's heated. The filament is heated to a required temperature, and that required temperature is to actually emit electrons. So if you get something hot enough in a vacuum, it will release electrons. And so that's the thermionic part here. And so they're basically overcoming the work function, if you want to think about it that way. So that's what the cathode is there for. So we need to heat it up in some way to emit electrons. Next, so that's the cathode that I've listed here. Next, the anode. So the anode is there to effectively allow a high voltage, in this case a positive voltage, to be applied between the cathode filament and then this anode. So it's basically there to give a positive, really high voltage. And the reason we want to do that is because these electrons that are produced are then accelerated because of this high potential. Right? So we put a really high positive voltage on this, and that will funnel these electrons towards the anode at a high speed. So that's the purpose of this anode, to accelerate electrons. And lastly, what's known as the Weinhold cap. This is actually biased, or a voltage is applied slightly negative. And so that might seem counterintuitive, since we just were talking about the anode, which has a positive voltage. And the reason we do this is because you'll notice that this Weinhold electrode or cap is basically forms a cap around the cathode, but it has a very small opening here at the tip of the cathode. And so what that does is that it basically, you want to block everything but through the small opening in the cap. And so we can do that if we bias the cap to be negative. And so it will basically suppress electrons in most areas, but will funnel them through the tip of the filament down towards the anode. So it's basically trying to make selective emission of electrons only through the opening in this Weinhold cap. So those are the three components that we see in this kind of thermionic emission gun. So this is like I said, the most common type out there. It's the cheaper, more sort of classic of the different options in emission guns. And so if you have a basic or slightly older SEM, chances are this is going to have this is going to be the emission gun. Also, the tungsten filaments tend to be very cheap with respect to the lab6 and also the field emission. And so that also plays a role in why these are selected. Okay, so let's look at these different types of filaments. Like I mentioned, tungsten's cost-wise is very cheap. And also, they only require sort of a low level of vacuum, so we don't have to have the really ultra high levels. And so if we look down here, requirement for vacuum, it's 10 to the minus 4 torr. And if you compare that to the lab 6 or the field emission types of guns, you see that that requirement is lower. And so not the same kind of pumps are required. And so the overall effect is that it's cheaper. So that's one thing that we want to mention. The other thing here is that the operation temperature is much higher. You can see that as opposed to these others. So obviously that's a drawback. And the other part of that, along with the temperature, is the brightness. You'll also notice that the brightness here, which is 10 to the 5, and the others are 10 to the 6, 10 to the 8. And so the brightness is lower. So even though it's cheaper, the operation temperature is higher and the brightness is lower. And lastly, if you can kind of imagine a tungsten filament, this is really similar to the filament light bulbs that are being phased out currently. The lifetime of those products, including this tungsten filament, are very short. And so even though they're cheap and have some of these advantages, they do have short lifetime. So you have to constantly replace them as opposed to some of these others. And so that's another thing that we have to think about. All right, so let's go into the other type. And I want to spend some time on this because these are the newer guns out there, and used in both SEMs and TEMs, actually. But they're more expensive, but they do give us some advantages here. So the main thing that you'll notice is that the temperatures required are much lower. So for the thermal, it's 1,000 degrees or 1,000 K, and then on the cold ones, we're basically operating at room temperature. And so the temperatures are drastically low. And it does this because it operates on a tunneling effect of electrons from the surface as opposed to that thermal emission. So this is a tunneling effect, not a thermal emission. So basically, instead of thermal, it relies on a really high electric field applied to the surface. And it also has, and it can also do that because we have a very fine tip. So these kind of show some zoomed in views of the different filaments. You can see here, if you really look at it, the tungsten filaments aren't super fine at the point. Lab 6 becomes a little bit more fine, and then the field emission are very small, and you can kind of go down to the nanometer scale to look at them. So that obviously allows us to have really high electric fields. And so the result of this, the fact that we're using this tunneling effect and we have lower temperatures, means that the result of it is that our brightness levels, 10 to the 8, are again 2 to 3 orders of magnitude higher than the other types of filaments. And so that's ultimately going to give us better image quality. So if you remember from light microscopy, brightness was a key component that we had to have for image formation. And so that's something that we want to have, is the highest brightness possible. And again, this configuration with the field emission guns allows us to have the smallest probe diameter of the actual beam. So that's another important thing. So we can have that because we have those higher brightnesses. So again, drawbacks, obviously the cost of this, and along with that, the vacuum levels are much higher. So we have to have different levels of vacuum. And so often that means we have to have more sophisticated vacuum pumps, which cost more. And so those kind of all go together in the same way.